I really have that one thing that you need to strengthen your solving skills. Solving is actually a skill. You learn that and be perfect in that in order to do wonders for yourself. And once you master the skill, listen, you're unstoppable in solving. So I have the best solution today and I'm going to express it to you. And let's begin with today's topic, that is mathematical induction. So this is related to MFCS, DMS, DMGT and Inter 1A. So now in today's video, we are going to use mathematical induction to solve the following, that is 1 by 1.3 plus 1 by 3.5 plus 1 by 5.7 plus and so on. 1 by 2n minus 1 into 2n plus 1 is equal to n by 2n plus 1, where n belongs to a natural number. So in order to solve this, I have taken mathematical induction. So here in the solution, let S of n be the statement. So here the nth term is also given. So in the first step, we have to select n is equal to 1. So after keeping n is equal to 1, so we have to check LHS and RHS. So this is LHS part and this is RHS part. In the LHS part, so what is given here? 1 by 1 into 3, which is equal to 1 by 3. So LHS value is 1 by 3. And see, in the RHS part, what is given? N by 2n plus 1. So in this also, if you keep n is equal to 1, see this will be 1 by 2 plus 1. So which is again 1 by 3. So both the values are equal. So we got LHS is equal to RHS. So we see that the statement is true when n is equal to 1. So in this statement, S of n is the statement. So this is the statement. If you keep n is equal to 1, then LHS is equal to RHS. And in the next step, so what we have to do? So we have to assume that it is true for n is equal to k. So this is our statement. And in this, what is our second step here? The second step is nothing but assume that S of k is true. So which means that if you keep n is equal to k, we have to assume that it is true. See here, so in place of n, so I kept n is equal to k. So here in place of n, after keeping n is equal to k, this will become k by 2k plus 1. So this is equation number 1. And in the third step, what we have to do? Now we have to show that it is true for n is equal to k plus 1. Now we show that S of k plus 1 is true. For showing that it is true, so actually what is our nth term? Nth term is nothing but 1 by, see here, 1 by 2n minus 1 into 2n plus 1. So in this, if I take n is equal to k plus 1, see here, in place of n, so if I keep k plus 1, so in place of 1, if I keep k plus 1, see what happens? So this will become, so this is 2k plus 2, this is minus 1, and this is 2k plus 2, this is plus 1. So actually this value is nothing but 1 by, this is 2k plus 1 into this is 2k plus 3. Now I am going to add this k plus 1th term on both sides of the equation 1. So what is our equation 1? So equation 1 is nothing but after keeping n is equal to k, we got this equation 1. So now I am going to add here and here. So in both the places. So I am going to add. So this is equation 1. Now I am going to add here and here. So now after adding, so this is the term. So this is equation 1. So after adding on both sides, so this is LHS and after adding on RHS. And now let us find out whether this is true for n is equal to k plus 1. So in the first equation, so after adding, see here. Now I am going to solve this. So in order to solve this RHS part, so this will be 2k plus 1 and this is also 2k plus 1 and this is 2k plus 3. And see, now if I take an LCM, so what will be the LCM here? The LCM part will be this value is 2k plus 1 into this value is 2k plus 3. Now there is 2k plus 1. So what is left over? 2k plus 3. So this is k times of this value is 2k plus 3 plus. So both are there. This value will be 1. So here this value, if I multiply so with k, so this will be 2k square. So the value here is, this is 2k square plus 2k square plus 3k plus 1 by this value is 2k plus 1 into this value is 2k plus 3. And clearly if I take factors, so 3k can be split into 2k plus k. So this can be split into this value is 2k plus k plus 1 by here the denominator is again 2k plus 1 into 2k plus 3. So here what I have done, so I have split this 3k as 2k plus k, and now if I take common 2k, so from the first two terms, if I take 2k common, this will be k plus 1, and here also this is k plus 1 by this value is 2k plus 1 into this is 2k plus 3. So if you observe this one, so k plus 1 and k plus 1 are common, and therefore if I take this k plus 1 common, then what is left over? This is 2k plus 1 by this value is 2k plus 1 into this value is 2k plus 3. So these two are the similar terms. This is 2k plus 1 and this is also 2k plus 1. After cancelling, so we got the value as this value is k plus 1 by this value is 2k plus 3. 2k plus 3. So this can be expressed as, so this is k plus 1 by this value is, so in place of k, I am writing k plus 1. So this is 2k, it is okay. 2 into 1, 2. So after taking 2 from 3, what is left over? This is 1. Now I'll check. So what is our nth term here? So nth term is nothing but, see here, this is our nth term, that is n by 2n plus 1. So here in place of RHS we have n by this is 2n plus 1. So in place of 1, if I keep k plus 1, so this is satisfied. So in place of 1, k plus 1, this is satisfied. Therefore S of k plus 1 is true. So we got a true statement. If you keep n is equal to, see here k plus 1, this is true, and therefore this is true for every positive integer, and therefore our statement here. So what is the statement here? That is 1 by 1.3. Therefore that is 1 by 1.3 plus 1 by 3.5 plus and so on. So this is the nth term, that is 2n minus 1. So this is 2n plus 1, which is equal to n by 2n plus 1. So this is how we have to solve. This is so simple if you follow these few steps here. First of all, we have to assume n is equal to 1. So we have to check LHS and RHS. If LHS is equal to RHS, we tell that it is true for n is equal to 1, and after that, so we have to take n is equal to k. So we have to assume n is equal to k and we have to keep it as equation 1, and later we have to check for n is equal to k plus 1. So this is the k plus 1th term. So I have to add k plus 1th term on both sides of the equation 1. So equation 1 which we got when we keeping n is equal to k. So after adding on both sides, so after solving the RHS part, see here, after taking LCM and solving, so we got the final result as this one. So this is nothing but after keeping n is equal to k, this is satisfied. Therefore S of k plus 1 is true for n is equal to k plus 1. Therefore it is true for 1, 2, 3, k plus 1, and therefore it is true for every natural number, and therefore the statement is true according to the mathematical induction. Thank you so much for watching, as this is a shortest video, and please pass it on to your friends and you learn from this, and the process is also very simple. So avail my videos and pass it on to your siblings, friends, and so on, and go through the playlist. So many videos are uploaded for your preparation, and definitely it will be very useful. Raise your thumb, subscribe to this channel, and stay connected, and have a look at my next video also. That is also very, very important. Stay connected. Thank you so much.